All right, see if we can straighten out number 45 and 17.1. Parameterize a line with points P and Q, 2, 5, and 12, 9 at some given parameter values. Okay, so how do you start?
Figure out displacement. That's it.
Okay, cool. So I should find a displacement vector. So what's your displacement vector you want?
10, 1, Q minus P.
Okay, so you took Q, thought of it as a vector, subtracted P, thought of it as a vector.
Yeah.
And you got 10, 4? Okay, then what? So what do you think about this thing? Like, what is that in relation to the line you're looking for?
Velocity vector?
Yeah, it's the velocity vector.
The slope.
It's the slope. Does that make sense that the velocity vector and the slope for a line are going to be the same thing?
Yeah.
Okay, so here's my slope. So what would my first thought of just get a line be?
Y equals mx plus b.
Okay, so I'd say really like maybe L of t, right, is
P, vector P.
okay. P thought of as a vector plus
Q minus P.
plus your slope, perfect, times t, right? But this doesn't do it.
No.
This blue line hits these at t is and p is.
Oh, T is 0 and 0 and 1.
Yeah, I hit it 0 and 1. Okay, so what do you do? How do you fix it?
Not sure.
T needs to be 0, or no, the whole T thing. Q minus P needs to be 0, T is 20.
Yeah, let's see. So I want this to be 0 when t is 20, right?
Yeah.
Okay, so let me try new line as a function of t, right? Like try sub 1, you know? Probably still go through p, right? And then we need our slope, so we need plus q minus p times, now when do I want to hit p?
At T is 20. So
At t is 20, so
a shift. T. Yeah. T minus 20.
right, I want to shift time back 20 units.
What do you mean by the t equals 1 and t equals 0? Is that correct?
Oh, okay, so these two blue guys correspond to the times when I get to p and q with this line.
How do you
This-
know that?
Oh, because if I plug t at 0 in, I have no slope, right?
Oh, okay.
So I'm starting just the vector p. And then when I get to 1, I've got q minus p plus p. The p and the minus p cancel, so I get q out. Cool with that?
That's not always happens.
Yeah.
Okay.
Yeah, when you write down this form of a parameterization, t is 0 always corresponds to the starting point you picked, and t is 1 always corresponds to the end of that displacement vector. But here I didn't want that, so I changed things, right? And now what do I have? I have this thing gets to p at t is 20. When does it get to q?
30.
Well, that's when I want it to get there, but when does this get there?
And the next one, 21.
Yeah, 21. Crap. You guys see that?
You do P over 10. Like,
That seems like a good idea. Right? Do I want to slow things down or speed them up?
Probably slow it down.
Yeah, I want to slow it down, right? Because I want it to take 10 units of time to get from P to Q, and it's only taking 1 now. So I want to slow time down. So I should...
so you can divide by 10?
Sure, yeah.
Okay.
So maybe instead I'll try like line version 2. Really, I should have called this one line version 1, right? This one being line version 0. Okay, so line version 2 should be maybe P plus my displacement vector, right? Q minus P. And then you think we want to do T minus.
Well, I was thinking to put.
You want to do.
You wanted to do P,
I want to
vector
do
P.
Vector P over 10. Is that?
Oh, that would also.
Yeah. Okay. That's a.
Well,
What, the entire thing divided by 10?
you could divide the
Yeah.
displacement vector by 10. Yeah, that would also work. Okay, let's just do that. Let's throw the 1/10 over here. And then you can put it on whichever piece makes sense to you.
Okay.
Right? Does that make sense? I mean, it's just scalar multiplication, right? So of
Yeah.
course it's commutative. You can put it on this scalar piece, in which case you're slowing time down. Or you can put it on this displacement piece, in which case you're taking a tenth of the slope.
Okay.
Does it matter?
No.
Nah, same thing. Does it work?
Yeah. Well, I'm not sure.
I don't know. How do we check?
Look at it.
Yeah, math. Good. Plug in T is 20. What do I get?
P.
Okay,
P.
so I go through P and T is 20. And when do I go through Q?
T is 30.
Probably at T is 30, right? Does it work?
Yes.
I get 10 times a tenth gives me 1, gives me perfect. Check. Whoops, is that what they wanted?
Parameterize.
It's parametric, isn't it?
Yeah, I parameterized an arbitrary line, right? They gave me points for P and Q. They probably want those
How
put
did
in
you,
there.
that 1/10, how did you guys come up with that?
So we realized that the difference between P and Q was 1 time unit, right?
Okay.
I wanted to make it 10 time units. So I needed to either multiply or
Because of
divide by
30.
10.
Because of the 30, right?
Yep.
T was 30.
Yeah, I wanted it to take 10 time steps to get from P to Q. It was only taking 1, so I need to slow things down. So I'm going to throw in a factor of a 10.
Okay.
And one way you can think about that is you've got your P vector here, you've got your Q minus P vector here. Here's your Q. Right, so all we're doing is we're gonna say, okay, right now if I run out a Q minus P, I get from P to Q in 1 step. If I cut this thing into 10 little pieces, then it'll take 10 times as long. Does that kind of make sense?
Yeah, I sort of, it's kind of weird.
Yeah, it's a little bit funny. They wanted me to give probably an equation with the numbers they gave me though.
Yeah.
So what if I throw those in?
So L here. Parentheses 2, comma 5.
Okay, so I start at 2, 5, and I add
10, 4.
10, 4
T minus 20.
times T minus 20. The heck? Zeros go this way. Times a 10.
Yeah.
And you could multiply that out a little bit if you really wanted to.
Don't want to.
I don't either. Cool. Questions, thanks?